Today we are learning the lesson for 5.1, linear functions and graphs. I've included here a table that represents Andrea's height as she ages. Notice when she's 10 years old, she's 60 inches tall, and when she's 18, she's 68. You may have also noticed that 68 is repeated twice, and you have to ask yourself, well, what does that mean? Well, chances are at the age of 16, she reached her maximum height, and then she'll just stay at 68 as the table increases in her age. We have several definitions that we have to look at. The first one is relation. So what I want you to do is to place the video on pause, and I want you to take out your textbook and look up the definition of relation. It is a pairing comparing two sets of information. Next definition, ordered pair. So again, put the video on pause and look up the definition of ordered pair. You'll see that each pairing can be written in the form of a grouping representing a point. So what I did here was I took each of the pairings of her age and her height and I wrote them in the form of a point. For example, 10 years old and 60 inches tall is the point 10, 60. And remember that all points are written inside parentheses, which obviously represents the point. You'll also see that I've taken all 5 of these points and I wrote them as a set, which means that they are inside those little squiggly lines called braces. And you are expected to include braces when you're listing these sets of points. Next, we have the definition of function. Again, place your video on pause and look up the definition of function. And you'll see that it is a set of points in which there are no repeated x values. Y's can repeat, just not the x's. The next definition is domain. Put your video on pause, look up the definition of domain. And it is the set of the first elements of each pair, and in other words, it's all of the x values of each point listed from greatest or from least to greatest. So here I just took all of her ages, 10, 12, 14, 16, 18, and I listed them inside braces. So that represents them as a set. Next definition is range. And it is the set of all of the second elements of each pair. For example, it's the y values of each point, again listed from least to greatest. So I took all of her heights, 60, 63, 67, 68, and I wrote them inside the set of braces. Notice that I have only listed 68 once, and that's because she's going to be 68 forever, so there's no use repeating that number, so it only gets written once. In other words, do not write any of the repeated digits more than once. Very important rule. Here we have our first example, and it says, determine whether each is a function and list the domain and range. So I've got 5 different points listed here, and you have to determine whether it is a function. What do? Well, you look at all of the x values, which is the first number in each of the sets of parentheses, and you see whether or not there are any repeated values. Notice that there are not any repeats, and what that means is it is a function. So yes, this is a function. Now we're going to list the domain. Keep in mind the domain is the set of all the x values written from least to greatest. And they have to be inside braces when you make this list. So all I'm doing is taking the x values, putting them inside braces, listing them from least to greatest. Keep in mind if there are any repeated ones, you only have to write that number once. Range, again, is all the y values. So I just look at all the second numbers in each set of parentheses and write them from least to greatest inside braces as well. Here's the next example. I want you to do that one on your own. So place it on pause and tell me whether it is a function, and then state the domain and the range. You'll have noticed that because the 8 is repeated, that means that it is not a function. The domain, again, are all the x values listed inside braces. There they are. Do not write any of the repeated digits more than once. Range, again, are the y values, and there's the list. Another definition, linear function. So place your video on pause and look up the definition of linear function. So it's a function that makes a straight line when graphed on a coordinate plane. Thus the prefix line for the word linear. So it makes a straight line when you graph it. So here I give you an equation, y equals 2x minus 1. I give you a table of values. With the x values listed, what you have to do is find the y values in order to make a point and then be able to graph them. So what I did was I take the value of x, which is negative 2, I substitute it into the equation y equals 2x minus 1, and I solve it using order of operations, or PEMDAS. I solve it for y, and I get y to be negative 5. I now take the negative 5, I place it in the table of values, and that now makes a point, negative 2, negative 5. I'm now going to graph it on the coordinate plane, keeping in mind that the x counts left or right, the y counts up or down. So x of negative 2 counts 2 to the left from the origin, and then the y, negative 5, counts down 5. So 2 left, down 5, and the point is right there. I now am ready to substitute y equals negative 1 in. So I plugged it in, I solved it using order of operations, I get y equals negative 3. I put that in the table of values, and I graph it. 1 to the left, and down 3. There it is. And I repeat for the 0, I plug it in, y is negative 1, I put that in my table of values, and I plot it. 0, negative 1. I want you to place the video on pause and complete the last two. So x equals 1 gives you y equals 1. Put that in the table of values, plot it. Substitute x equals 2 in, y equals 3, put that in the table of values, and plot it. Once you've got the 5 points, you are now ready to draw your line. These points should be on a line. If one or more points is not, you do not make a squiggle line or a zigzag line. These have to make a straight line, and something will have gone wrong, and you have to figure out which points are wrong. It's probably the ones that are not on the straight line. So there's my straight line. I connected it. Don't forget that you do need an arrow at both ends. In the final example, 4x plus 2y equals negative 6. Same format. Start by plugging in x equals negative 2 into the equation. I do that, I get y equals 1, put it in the table of values, plot the point. I now am going to substitute y equals negative 9 into the equation. So I do that, I get x to be equaling 3. I put that in the table of values, and I plot it. I do the same thing for the remainder of the 3 numbers. I want you to place the video on pause and find those 3 numbers. So when y is equal to 5, x equals negative 4, put that in the table of values, plot it. Put x equals 1 into the equation and solve it. Y equals negative 5, put that in the table of values and plot it. And finally, place in y equals 7. You'll find that x equals negative 5, put that in the table of values and plot it. At this point, you now draw your line, making sure that the arrows are on both sides, and you are complete. So for homework, we are going to do page 224, numbers 13 through 31, number 35, and number 36. I hope you enjoyed this lesson. Thank you Thank you for being in my class today.